Okay, for question number 5, we're going to take a little deeper dive into how these parameters are affecting our graph and if there's even more information we can get from them. So I have 3 functions here. I have y is ab to the x, y is cd to the x, and y is pq to the x. So we've gotten rid of all the numbers, and we're going to see what we can determine just from looking at this picture. So we have several different questions here, which constants are definitely positive, which ones are definitely between 0 and 1. And it's really easy to get overwhelmed with these questions and all of these letters. So my advice here is let's start by figuring out what we know about these. So we know that this number in the letter in the first spot that doesn't have the x is where we're crossing our y-axis. So that means right here that according to this function, that's a. And according to this function, this place where we're crossing the y-axis is also c. And then up here, this is going to be p. So we have those marked out. And then what else do we know? Well, we know here that this is increasing, which means that q must be greater than 1. And this one is also increasing. So we know that d, which is the part raised to the x, is also greater than 1. And here, this function is decreasing, which means that we know that b is between 0 and 1. Okay. So now that we've kind of written down some things that we know just from looking at the picture, let's see what we can do to answer these questions. So question A, which of these constants are definitely positive? Well, we know B, D, and Q are all positive because we've already assigned that they're either greater than 1 or greater than 0. We can put those down. And then we have A, C, and P left. And if we look here, this is where the x-axis is. So this is where y is equal to 0. So anything above here, y is going to be positive. So that means A, C, and P are all positive. Okay. Which of these constants are definitely between 0 and 1? Well, we can eliminate Q and D because we've decided those are already greater than 1. B is certainly a possibility, so we'll write B down. And then we have these intercepts left here. And the thing is, we know that these are all positive, but we have no idea exactly what that value is. Okay, so maybe the scale on here is that this is 1. And so all of these would be between 0 and 1, but maybe the scale is that this is 10. And so 1 would be down here. We just don't know. Okay, and so since the question says definitely, B is the only one we know is definitely between 0 and 1. Question C says, which two of these are definitely equal? We know for a fact, beyond a shadow of a doubt, that these are absolutely equal. Well, we know that these are A and C are definitely equal. Okay. We don't have any idea about the rest of these. We know P is not equal to A and C. We know that B is not equal to Q or D, but we don't know how Q and D relate. That's kind of a question mark. Okay, so A and C are the only two we know for sure. All right, here's what I'd like you to do for question D. Which of the following pairs could be equal? Okay, so we don't know for sure, but we can eliminate some of these that we know are definitely not equal to each other. Okay, so I'm going to have you pause the video and see if you can identify which ones are definitely not equal, and then we can talk about what's left over. So give that a pause. Okay, so let's talk about this. So the first one is A and P. Well, here's A and here's P. They're definitely not going through the same place on the y-axis, which means they have different y values. So this is definitely not going to work. B and D. Well, we know B is between 0 and 1, and D is definitely bigger than 1. So there's no overlap there. In fact, if we wrote that as a series of inequalities, it would look like this. So B is between 0 and 1 with D bigger. So definitely not equal. And B and Q, so here's B, here's Q. So we can make that same argument that we just made here, that B and Q cannot be equal. So that just leaves this one, D and Q. And let's see what we know about D and Q. So we know D is bigger than 1. We also know that Q is bigger than 1. Okay, so there's no contradiction there. It's not like Q is less than 1, D is definitely bigger than 1. They're both bigger than 1. So it is possible that they could be equal, and we would need more information to figure that out. But since it only asks could, we're going to circle D and Q.